Good morning, student. This is Latif sir. Before I start today's topic, I want to say you something that I think you have seen the reduced chemistry syllabus for 2021 board exam. If you have not seen, just check the council website and download the reduced chemistry syllabus. I have seen that many topics in a chapter are excluded from the board exam syllabus. So you have to prepare yourself according to the reduced syllabus of all subject. And I am also following the reduced syllabus. Okay, so just check the council website and download the reduced syllabus uh, and see the reduced syllabus, which topics are given in the reduced syllabus, which are excluded from the syllabus, which topics are excluded from the syllabus for your 2021 board exam. Okay, let's start today's topic. Today I'll discuss about quantitative aspects of electrolysis. Scientist Michael Faraday was the first scientist who described the quantitative aspect of electrolysis. Michael Faraday was the first scientist who described the quantitative aspect of electrolysis. Faraday's law of electrolysis. Let's see the Faraday's law of electrolysis. After his extensive investigations on electrolysis of solution and melts of electrolytes, Faraday published his result during 1833 to 34 in the form of following well-known Faraday's two laws of electrolysis. I have told in the previous videos that when electricity is passed through a electrolytic solution or through a molten electrolytes, you will see that the electrolyte will dissociate into ions, and positively charged ion, that is cation, goes to cathode and anion goes to anode. You know that is cations deposited at cathode and anion deposited at anode. And you can say the amount of substance deposited at cathode or anode at electrode using Faraday's two laws. So according to the Faraday's first law of electrolysis, Faraday's two laws, you have to read the Faraday's two laws. The first law of Faraday is the amount of substance deposited during electrolysis is directly proportional to the quantity of electricity passed. I have told that when electricity is passed through a electrolytic solution, different substances deposited at cathode and anode, and the amount of substances deposited during the electrolysis is directly proportional to the quantity of electricity passed. If more electricity is passed, you will get more quantity of substance at the electrode. If less electricity is passed, less amount electricity is passed through the electrolytic solution, you will get less amount of substances at the electrodes. So according to first law of Faraday, the amount of substances deposited, that is W, which is represented by that letter W, is proportional to the electricity quantity of electricity passed. If I ampere current is passed in t second time, if I ampere current is passed in t second time through a electrolytic solution, then the amount of substance deposited W is proportional to I into T. And you have to replace the proportionality sign with equal sign. That's why you have to multiply the value I into T with a constant. Here the constant is Z, that is W is equal to I into T into Z, I into T into Z. And you know that I into T, that is current into time, which is also known as charge. So charge Q is equal to I into T. Total charge passed through the solution is Q is equal to I into T. If I ampere current passed in T second, then total charge passed through the solution is Q is equal to I into T. So W is equal to I into T into Z. You can also write W is equal to Q into Z, because Q is equal to I into T, where Q is the quantity of charge in coulomb and Z is the proportionality constant, which is called electrochemical equivalent. Z is called electrochemical equivalent. When the value of I is 1, value of T is 1 second, and Q, if value of Q is 1 coulomb, then W becomes Z. When I and value of I and T or value of Q is 1, then W is equal to Z. That is amount of substance deposited is equal to electrochemical equivalent. So what is the definition of electrochemical equivalent? Electrochemical equivalent, Z is the amount of substance deposited or liberated by passing 1 ampere current in 1 ampere current for 1 second, or by passing 1 coulomb charge through the solution. Now Faraday's second law of electricity. According to the second law of Faraday of electrolysis, if same charge is passed through different electrolytes, the mass of substance deposited will be proportional to their equivalent weight. If same charge is passed through different electrolytes, the mass of substance deposited will be proportional to their equivalent weights. So according to the Faraday second law, the mathematical equation is mass of A, if the substances deposited at 2 electrodes, the substances are A and B, and their mass is W1 and W2. If the mass of substance A and substance B deposited at 2 electrodes, or deposited at electrodes, or liberated at any electrode, then you can write mass of A by mass of B is equal to equivalent weight of A by equivalent weight of B, and mass of A is W1 and mass of B is W2, and equivalent weight is generally represented by the letter E. So equivalent weight of A is E1 and equivalent weight of B is E2. So according to Faraday's second law, W1 by W2 is equal to E1 by E2. And again, E1 is W1 means, according to first law of Faraday, W1 means Z1 into Q, and W2 means Z2 into Q. Here in the second law of Faraday, it is mentioned that if same amount of charge is passed, that is in the both the cases Q charge is passed, that's why Z1 into Q divided by Z2 into Q is equal to E1 divided by E2. Now we know that charge of one electron is equal to 1.6 minus 1.6 into 10 to the minus 19 coulomb. So the value of charge of electron is equal to 1.6021 into 10 to the minus 19 coulomb. Therefore, charge of 1 mole of electron is equal to 1 mole means Avogadro number electrons. So Avogadro number, if Avogadro number is represented as Na, and charge of one electron is E, then charge of 1 mole of electron is Na into E, and value of Na is 6. Value of Avogadro's constant is 6.02022 into 10 to the 23, and charge of one electron is 1.6021 into 10 to the power minus 19. Here just see the value of Avogadro constant. It is actually 6.02022 or 023 into 10 to the power. Here it is not written as 10 to the power, it is just 1023. Okay, just correct this value of Avogadro's constant, that is 6.02 into 10 to the power 23. Just write 10 as 10 to the power 23. And charge of electron is 1.6021 into, here you have to give 1 in multiplication sign, into 10 to the power minus 20 coulomb. So after multiplication of Avogadro's constant and charge of one electron, you will get the value of charge of 1 mole of electron, which is approximately equal to 96,487 coulomb per mole. And this quantity, that is 96,487 coulomb per mole, is the charge of 1 mole of electron, which is called Faraday's constant, and it is represented by the symbol F. So 1F is approximately equal to 96,500 coulomb per mole. 1F means 1 Faraday means 96,500 approximately, but actual value 96,487 coulomb per mole. You can also use 1 Faraday as 96,500. Now let's see for the electrode reaction. Here I have taken some electrode reaction. First electrode reaction is silver plus 1 electron implies Ag solid. When silver plus ion in aqueous solution accept 1 electron, it reduced to silver atom, that is solid silver metal. So for the reduction of 1 mole of silver plus ion to silver metal, the electrons required 1 mole. For 1 mole of silver, reduction of 1 mole silver plus ion, the electron required is 1 mole. That is 1 mole mean total charge is required 1 Faraday, that is 96,500 coulomb. So 1 mole of electrons, that is 1 Faraday, that is 96,500 coulomb charge or electron total charge. 1 mole charge of 1 mole electron I have told 96,500 coulomb per mole. So for 1 mole of electron, that is 1 Faraday, is required for the reduction of 1 mole of silver ion. Similarly, see the reduction of magnesium 2 plus ion to magnesium metal. So Mg2 plus in liquid plus 2E, Mg2 plus accept 2 electron to form Mg. So 2 mole of electrons, that is 2 Faraday charge, are required for the reduction of 1 mole of magnesium 2 plus ion. For reduction of 1 mole magnesium 2 plus ion, 2 Faraday electricity, that is 2 mole electricity, that is 2 into 96,500 coulomb, total charge is required for reduction of 1 mole magnesium 2 plus ion. Similarly, for the reduction of aluminium 3 plus ion to aluminium metal, so according to the equation, Al3 plus 3 electron to form Al, aluminium metal. So according to this equation, 3 mole electrons, that is 3 Faraday total charge are required for the reduction of 1 mole of aluminium 3 plus ion to aluminium metal. Here one numerical problem is given. The question is, a solution of copper sulfate is electrolyzed for 10 minutes. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. So 1.5 ampere current is passing through a copper sulfate solution for 10 minutes. Now question is, what is the mass of copper deposited at the cathode? So you have to calculate the amount of copper deposited at the cathode. And here the data given, current is passed 1.5 ampere for 10 minutes. So total charge passed through the copper sulfate solution is equal to Q is equal to I into T. So Q is equal to I into T. According to this equation, total charge Q is equal to 1.5 into T. T is 10 minutes, but you have to convert the 10 minutes into second. So 10 into 60, so 600 second. So total charge passed is 1.5 into 600, that is 900 coulomb. And according to the reaction, that is copper 2 plus 2 electron implies copper metal. This is the reduction reaction in the copper sulfate. When electricity passed through the copper sulfate solution, copper ion from the aqueous solution of copper sulfate reduced by taking 2 electrons. One copper 2 plus ion reduced by taking 2 electrons. That's why 2 Faraday electricity is required for reduction of 1 mole of copper 2 plus ion. 2 Faraday means 2 into 96,487 coulomb charge is required for reduction of 1 mole copper 2 plus, or when you pass 2 Faraday electricity, according to the equation, Cu2 plus 2 electron implies Cu solid. According to this equation, if 2 Faraday, that is 2 into 96,487 coulomb charge is passed through copper sulfate solution, copper deposit, the amount of copper deposit will be equal to 1 mole, or 1 mole copper means 63 gram of copper. So 2 into 96,487 coulomb can deposit 63 gram copper. Now I have told that total charge passed is 900 coulomb. So by using unitary method, you can calculate the amount of copper deposited. So you know that 63 gram copper deposited when 2 into 96,487 coulomb charge is passed. So when 2 into 96,487 coulomb charge is passed, 63 gram of copper deposited. Then when 900 coulomb charge is passed, then mass of copper deposited is equal to 63 into 900 divided by 2 into 96,487. That is, the value is 0.29 0.38 gram. Okay. Now products of electrolysis. The product of electrolysis depends upon the nature of electrolyte being electrolyzed and the nature of electrodes. If electrodes if electrode is inert like platinum or gold, they do not take part in the chemical reaction. That is, they neither lose or not gain electrons. But if the electrodes are reactive, then they will take part in the chemical reaction and the product will be different as compared to the inert electrode. And second point, the electrode potential of oxidizing and reducing species. Some of the electrochemical processes, although feasible but slow in their rates at lower voltage, and these require extra voltage, that is over voltage, at which these processes will take part. And the product of electrolysis also differ in motion in molten state and in aqueous solution of electrolytes. So product of electrolysis depend on two factors, on the nature of electrolyte and electrode potential of oxidizing and reducing agent. And remaining one point I am saying that the remaining part of this chapter are excluded from your board syllabus. That is cell, what is cell, what is primary cell, secondary cell, corrosion, this rusting, this topic excluded from your syllabus. That's why I will not explain, or I will not discuss about this topic. Okay, so this is last video on this chapter, that is chapter 3. Okay, next day I will start a new chapter.